Oh boy, Windows. I mean, I'm on the test version because
I know, but
for 369 I have to use 16 bit. Because the subsystem has to Linux kernel.
Okay, so welcome back, everyone. I'm glad to see so many people back, that we're all back from break. Who wanted to do a bunch of stuff and didn't get it done over reading week? Yeah, exactly. Me too. That's exactly where I'm at. It happens every reading week. You always say, I'm going to study 4 chapters a day, and I'm going to memorize everything. And it never works out. So, I mean, happens to lots of people. I'm glad to see that a lot of people filled out the reflection on learning. So thank you for doing that. I got a couple emails over the weekend saying, oh, I missed the reflection on learning. Can I still do it? No. But that's all right. There's going to be another opportunity to do one of these in week 12. So I took all the comments that you sent in and I sent them to the TAs. So the TAs know who's been naughty and who's been nice. So the TAs know how to improve. They're thankful for your comments. And then all the stuff for the instructors, all the comments for the instructors, I set those aside as well and looked at them. So I read through the comments that you gave me. So I read through these and I'm very, very thankful for them. So one says, the lectures are not a good representation of what might show up on homework and assessments. Okay, that's very good. So we'll try and make the lectures align better with what's in the textbook. Or there's one, the textbook has much more material. I look at the learning objectives, but some things aren't in the learning objectives and still come, so I don't know what's actually in this course. This is a nightmare. But it's good to know that someone feels that way. So I'm happy that comment came in. So when a prof chooses a textbook, right, the textbooks are made for us, right? They come already written. So we have to pick the parts that we want to teach. So I've been trying to teach just the learning objectives. So supposedly, if you come to lecture and read the textbook and look at the learning objectives, it should match, but I see there's still there's a disconnect. And then the lecture is too easy. Okay, don't worry, I've got you covered. We can make it harder. But that's good to know. So it's good to know there's a mismatch between what we're doing in lecture and what's in the homework. Class materials are too easy and probably doesn't reflect the difficulty of tests. I tried to keep it sort of on par, the term test, with what we're doing in lecture. We'll see, but I'm taking these comments. I want you to know that I've read them. I'm thinking about them. I'm going to try and make the learning objectives in the lecture match better. So the quizzes, learning objectives, test, and the lecture should match. Okay, and we'll keep posting lecture videos. Very good. Yes. I get the sense people probably have questions about the test. Are there things you would like to talk about with our term test? Yes?
So if it's not in the learning objectives, we don't have to worry about it?
Yes.
Okay.
Good. So yeah, so I just, I thought this would be, oh, whoops, that's week 11. That's way in the future. We are in week 6. Right. So yeah, so I thought I post this stuff up, but I haven't actually said how to use this information. So when we see the learning objectives, it says recognize and use some properties of double integrals, evaluate a double integral over a rectangular region by writing it as an integrated integral, use double integrals to calculate volume under a surface, average value of a function. Okay, so let's look at the book.
This is
Right, so we're looking at the book, and there's all this crazy stuff. Ah! What on earth is going on there? Right? This isn't evaluate a double integral or use a double integral. This is some crazy Riemann voodoo. That's what it is. So when you're reading the textbook, if it's not covered by learning objectives, just skip. Okay, good. Double sums. Ah, properties of double integrals. Okay, those were mentioned. Yes. Use some properties of double integrals. Okay. So this is the kind of stuff that you take this, you print it, you go to your tattoo shop. Say, I need a real quick job, man. Get this, and you get it here. Please don't do that. But this is an important thing. So when you're reading the textbook, this is a good indicator of something that we care about. Aha, iterated integrals. Write it as an iterated integral. So so these guys are relevant to our interests. Okay. The goal is to sort of match these two lists up. So it says calculate the area, volume, and average. Okay, so all right, so we have to evaluate integrals up like this. We've got an area, stuff like this. Okay. So the learning objectives should be a reading guide to what to pick out, and it should match the exercises. That's the goal. Are there other thoughts, questions about the test, things people would like to know? Yes?
I was wondering if this week's material is going to be on the website.
No. So this week, so the material we introduced this week is not covered on Friday. Okay? The midterm only covers material before reading week. Yes?
What if there's a question on the test, but then we don't solve the way you do, but we solve the textbook explained?
Great, yeah. So the graders are going to look for both solutions. Yeah? So yeah, you'll get equal marks for basically anything that's correct. I believe in equality and truth. If something's true and equal to something else, then it should get full marks. Okay? Yes?
Oh, in the test, it said they were looking for like complete, it's like short answers and they're just looking for the answer in general.
Yeah.
How about if you screw up one little thing that ended up being
Then you're screwed. If you're looking, so what's going to happen is the grader's only going to look in the box. So there's these little boxes on the test, and it says, like, put your final answer here. And we're only going to look at that. So for that kind of thing, there's a lot of pressure, right? It's a lot of pressure to do the arithmetic correctly. So I encourage you to if you have extra time, to go back and double check those answers. Other things, other questions or comments there? Yes?
like, say difficulty-wise, would it be equivalent to the textbook numbers, questions, exercise? Yeah.
I'm trying to keep it like the quizzes. So there's 2 questions that are very, very, very similar to the quizzes. So you've written those. It'd be similar to that. Yeah, sure. There was a video posted talking about how to get ready. It's so ugly. So the very last bit of the video. Oh, do we have audio? Anyway. The last bit of this video talks about how to get ready for the test, and there's some suggestions here. Yeah? Okay. Yes?
Is there any past tests we can do?
No. Those haven't been posted. Just for the reason that the coverage is different. I don't want you to stress out about things. So the best way to get ready, the best way to prepare is to look over the quizzes and look over the assigned exercises. Hello, welcome. Okay, so just with the folks who are just coming in now, the main takeaway is we have a test on Friday. And the other thing is the material that we do today and Thursday will not be covered on the current term test. It'll be covered on the term test in late November. So up until now, we've been looking at stuff about differentiation. We've been taking derivatives, taking gradients, we're generalizing the notion of slope to several variables. Now we're going to switch over to the other side of calculus, the techniques of integration. Okay, so before we switch to multivariable integration, I want to quickly do a review of single variable integration, say what it means and how we can generalize it. Okay, so if we've got an integral between a and b, then what this thing measures is the signed area of f of x. Signed area of f of x between a and b. So the reason that we say signed here is if this function goes underneath the axes, right, so if our function's positive, it dips down, becomes negative, and then goes positive again. This stuff counts positively, and this stuff counts negatively. Okay, so we get a measure of area that depends on whether you're above or below the x-axis. That's sort of our notion of sign. And then a major tool that we use to evaluate these is our fundamental theorem of calculus. get the integral as a difference, these antiderivatives. Okay, so there's this whole elaborate art of finding the antiderivative, but we can find the area under a function by just looking at the endpoints. Okay. So what integration lets us do is it lets us go from a function f of x to an area. Okay. So now when we go one dimension up, right, if we have a function of two variables, and we do this same process, we should get not an area, but a volume. Okay, so this notion of integration takes functions to areas, or sorry, functions of one variable to areas, functions of two variables to volumes.